Alright, so I'm back here. I reopened my scene after saving my progress, reloaded it, and everything seems to be working just fine. So just try to bear with the Maya bugs. They happen every now and then. So in the last video we saw that we applied the bump shader, the bump map, to the skin shader. So let's go ahead and open up the attribute editor for the skin shader here. Minimize that hypershade. And I actually went ahead and if we go here to view, let's go to bookmarks. Here's my final rendered bookmark. Let me go to that one right there. Okay. So if I go here, we have a lot more attributes here. We have things like light map, algorithm control, and specularity. So specularity is going to control the shininess and reflectivity of the object. You get two layers of specularity, a primary specular and a secondary specular. Okay. Now, because this object is a jellyfish and because it's underwater, you're actually not going to see any specularity. So theoretically, I shouldn't be using any specularity. I should probably turn it off, but I'm just going to leave it on for now. And let me give you a quick rundown of what these parameters do and how they work. Okay, up here, just like with the subsurface scattering layers, you know how we have this diffuse color area up here that controls the overall color, overall diffuse, stuff like that. Well, for the specularity, we have a similar thing here. We have an overall weight, and we have this edge factor, which is an overall edge factor. Now, the edge factor is the same thing as Fresnel reflections. If you remember from the previous chapter with the architectural shader, how we were controlling the reflections and the shininess of objects using Fresnel reflections to push the reflections toward the edges of objects So just like with the Fresnel reflections of the architectural shader, this works the same way. This pushes the shininess of the specularity toward the edges of the object. Now again, this object is underwater, so probably wouldn't have any shininess. It wouldn't be visible, except for if you took the jellyfish out of the water, then you probably would see specularity. But that's the way that this works here. So that's the edge factor. Now the primary specular color works in conjunction with the secondary specular color. So the primary can be used to do some primary specularity, so some shininess, so if something looks a little bit oily or shiny. And then you can use the secondary specular color to really emphasize, say, wetness on the surface of skin. So if you had a human character, human skin that you were doing in a project, and you needed to do a character that had really wet skin, you would want to use this secondary specular color to add that extra wetness look to the skin. And we have, of course, the secondary weight. If we turn that down to 0, that'll turn off the secondary weight completely. Default setting is 0.3. You see that the primary weight also has a setting of 0.3. Okay. Now the primary and the secondary specularities each have their own edge weight. So again, the edge weight works just like with the edge factor up here. It's a Fresnel reflection type of edge weight, where the primary specular color in this case would be pushed towards the edges of the object the higher this edge weight is. So if we lower this edge weight, specularity is going to be broader across the whole skin. If we go ahead and push the edge weight to a higher number, like 0.8, which is the default here, then the primary specularity is going to be more visible at the edges of the object. Okay, and then we have this primary shininess. Using this primary shininess, we can actually create the shininess in similar to the architectural shader when you use glossy reflections. So we can make the shininess more pronounced or make it more blurry and softer. So that's what this primary shininess is for. Down here in the secondary specularity, we have the same exact parameters. We have an edge weight. We also have a shininess, okay, and of course the secondary weight here that can be used to control this the amount of secondary specularity. So if you wanted a lot of secondary specularity, you can increase this to say 1. If you wanted this to be pushed towards the edges of the object, more like a Fresnel reflections, you would put this to 1. And if you wanted this to be very, very shiny looking, like sort of like a blurry type reflection, you would increase this. And right now it's set to 33, which is a pretty good setting for that. So I'll set this back to 0. Set the secondary weight here back to, let me see. This was set to 0.3, I believe. And of course we can control the colors. And if you want to, you can actually plug in maps to this. So you can choose what parts of the object or what parts of the skin get these different specularities. So let's say you're doing a human character and they were supposed to have droplets of water on their skin. you can actually, or just have streaks of water that left some wet streaks on the skin, you can actually plug in maps of your character onto these different primary and secondary specular color slots, and you can actually really have a lot of fine-tuned control over the way that wetness looks on the character's skin. Down here we have reflection parameters. By default they're turned off simply because these are ray trace reflections and they'll add render time. So reflection weight is set to 0, that means that it's off. If you want to turn on reflectivity, you would go ahead and turn this to on. So let me actually go in here and do a render of this. And this is what we have. So I'll do render region here. Okay, and I'm going to take the reflection weight here and put that to 1. And I'll leave the edge weight to 0. That works again just like the other edge weight parameters and just like Fresnel reflections, where if you increase the edge weight here to say something like 1, it's going to push reflections toward the edges of the object. Okay, in this case it was set to 0, which means that the whole object uniformly reflects. The ray trace. Edit that out of the video. Starting in 3, 2, 1. And if you leave this at 0, it basically means that the object is going to have broad reflections all over it. The reflections are not going to be at the edges. And reflect environment only, if you have an environment shader plugged into your scene here, you can actually turn this on so that you reflect only the environment. The benefit to that is when you do environment only reflections, your render goes by a lot faster, because reflecting an environment shader is a lot faster than reflecting ray tracing rays of the actual scene, which takes a lot longer to render. So keep that in mind. So let me go over here and do render region. And then you notice that there's also this reflex shininess, which is set at 2 right now. The reflex shininess controls the shininess of the reflections. So just like with the architectural shader and the blurry reflections, the blurry glossy reflections, giving this thing high reflection shininess is going to basically create blurry reflections, which again are going to take longer to render. And if you lower this value down to something like 0, in this case 2, you're going to have sharper mirror-like reflections. Works just like with the architectural shader. So this is what we have. This is the before. Oh, and actually, you know what? I didn't save the before. Silly me. Let me right click. Let me go to remove all images. And I'll just save this one here. And I'll take the reflection weight, knock that down to 0. I'll do a render region of this. Sorry about that. So here we go. So here it is without reflections. Here it is with reflections. Okay, no reflections. And here's reflections. You can see here, obviously, you can see the reflections here from the lighting in here inside this top part of the jellyfish. Not a zoologist, so I really don't know what that's called. But I'll just refer to it as the top part of the jellyfish. So there you go. Here's reflections. Here's no reflections. Okay. You notice that when we do no reflections, we render in 5 seconds. When we do reflections, we render in 7 seconds. So adding reflections actually added 2 whole seconds of render time. So it's very important to understand that adding reflections to the skin shader can really increase your render time. So just be aware of that. Be careful about that. And if you have to use reflections, be sure that that's what you're going to use. And again, you can use the reflect environment only parameter to cut down that reflection rendering time by a huge amount. So keep that in mind. Okay, so that's going to do for specularity here. Let me go ahead and collapse those parameters. Then we have light map parameter. If you notice, there's this graininess on the jellyfish. Let me close that. Let me come in closer. Do a closer render here so it's really obvious what I'm talking about. Okay, so you can see it. There's this graininess, especially at the edges here, and you can see on the tentacles there's a ton of graininess. Let me go ahead and let me save this image out. Okay, and you'll notice here in the light map, we have a light map plugged in here, which is the Mentorate Texture 1. And if we go to it by clicking on that little input icon there, we can see what we get taken to. We get taken to that Mentorate texture that we talked about earlier that has those expressions. Okay, so let's hit this output button here to go back. And mine doesn't want to go back. So what I'll do is I'll just go into Hypershade here and double click there on the actual shader. And there we go. Now we're back. Okay, so samples. Now the samples by default are set to 64. The lower the amount of samples you have, the faster you're going to render. but the lower quality the light map is going to be, which is why we see this graininess here. Okay, so what we have to do is increase the samples here of the light map. Now you should go by powers of 2, so values like 16, 32, 64, 128, 256, 512, so on and so forth. So let's do render region of this jellyfish here. Okay, so we still have some graininess. Let's compare it to the before. Here's the before and here's the after. There's a huge difference. The before has a ton of graininess. The after has a little bit less graininess, but it still has some graininess. So what you need to do is continue to increase this. So let's increase it to 256. Let's save this one. And let's do another render region. Okay, so now we have a lot less graininess. If we go back, we can compare. So here's the first one. This is 64 samples. Very grainy, very nasty. This is 128 samples, twice the amount. Looks a lot better, but still has some graininess to it. And then here's 256, much less artifacting, barely any artifacting. Still has some though, and less graininess. So let's increase this to 512. Okay, and let's save this one. Do another render region. Okay, so there we go. It only took 1 more second to render, so it slowed down by 1 second, which is practically nothing. And if we look at the before, okay, let's look at this all the way back. This is 64 samples here. Not very good. A little bit better, but still not good enough. This is 128. This is 256, so it's a lot better. Still a little bit of artifacting left. And then 512 pretty much comes in and cleans up all that extra artifacting. Now there is a little tiny bit of artifacting down here on these tentacles. Okay, a lot of that can be, you can get rid of that using anti-aliasing, because right now we're using pretty low anti-aliasing parameters, so we can get rid of that with anti-aliasing. Of course, you can also increase the amount of samples on the light map, but I'm not going to do that because I really don't see the need to do that. Okay, down here we have an algorithm control. We have 2 main parameters here, which is scale conversion and the fall off. Okay, these are very important parameters. The scale conversion tells the shader what scale to work with. Alright, so here's what I'm going to do. Let me close that. Let me go back to view. I'll go to bookmarks, go to final render, and I'm going to do a render. And I'm going to do it at these current settings. So a scale conversion of 1 with a fall off of 2. Okay, and this is what I have. Let me go ahead and right click here on the remove image icon and remove all images. I'm going to save this one here. I'm going to take the scale conversion and I'm going to reduce it. I'm going to go from 1 to 0.1. Okay, and I'm going to go ahead. I'm actually doing a render region here, so let me cancel that. Don't want to do a render region like that. Let me do a render region of this. Okay. Okay, so here's the before and here's the after. This is with a scale of 1, and this one is with a scale of 0.1, 0.1. You can see that the smaller scale, the 0.1, is a lot grainier and has a lot more artifacting, okay? And this one doesn't. So it's very important to know what scale to work with. So how do you know what scale to work with? Well, by default, the scale will be set to 1. Usually that works pretty good. For, most of the time, I'd say about 70% of the time, maybe even 80% of the time, that works just great. But sometimes you will run into an instance or a circumstance, a project that requires you to tweak and change the scale conversion. So if you see that increase in the samples to say something pretty high, which is 512, and that's actually pretty high, and you still are getting a lot of graininess, which is not really my case here, but if you were getting a ton of graininess, then what you need to do is stop increasing the samples so much. Just leave it alone at 256 or 512. Don't go really higher than that. There's really no need to. What you would need to do is check your scale. A scale of 1 might not be good enough. You may actually have to decrease or increase your scale. Now, there's no magic number for every specific scene. So some scenes will look good with a scale of 0.1, some will look good with a scale of 1, some will look good with a scale of 0.5, some will look good with a scale of, I don't know, 15. It really depends on your scene and your project and the scale of your scene and project. So again, most times scale of 1 works fine. But sometimes you got to tweak that, so be aware of that. So I'm going to leave it at a scale of 1. Now the fall off controls the amount of fall off here for the subsurface scattering effect. So by default it's set to 2, which looks pretty good. Now if we take this fall off and we say we decrease this to, I don't know, 0.02, which is a very small amount. Let's go ahead and let's do a render region of this. Okay, that's what we have here. You can see the subsurface scattering is strong at the top, and it starts to fall off when it gets further down into the skin. That's because there's a light right up here. If there was a light down here, it'd be a totally different case, but in this case there's a light up here, so subsurface scattering effect starts to fall off. You can really see it on these tentacles. Okay, now that's a value of 0.02. Let me save that out. Let me take this and let me do a value of, say, 20. And let me go over here and do a render region. Okay, let me go back and compare. Here's the before and here's the after. Now the effect is extremely subtle. It's very difficult to catch it. But here it is with a fall off of 0.02, and here it is with a fall off of 20. Basically, the lower your fall off, the stronger the suppression effect is going to be on the subsurface scattering. So if you drop your fall off to something very low, then the subsurface scattering effect will not be that strong. It's going to reach out to less of a distance, so to speak. And if I go to the new render here, the new render was done with a fall off of 20. The higher the fall off, the farther that the subsurface scattering effect can reach, or the stronger it is. So you see here it's fall off of 0.02. The subsurface scattering is a little bit weaker. On this image here, the subsurface scattering effect gets a little bit stronger, and that's with a fall off of 20. But I'm going to leave it alone at the default setting of 2. This setting at the default setting is actually pretty good. You'll rarely have to change that setting, except if you are running into some kind of problem and the only way to fix the problem is by tweaking the fall off, then go ahead and do it. But for most intents and purposes, a fall off setting of 2 will work out just fine. Okay, so that's the algorithm control. So again, use the light map control here to control the quality of the subsurface scattering effect. If you're getting some artifacts there, increase the samples. If you're still getting artifacts even with high samples, then you may have to go ahead and adjust your scale conversion factor over here. Okay, so that's going to do it for the skin shader. It's actually pretty easy to use once you understand it and once you get around to using different parameters and things. So you can see how that works. Go ahead and explore this scene just so you can get more familiar with how the shader works and how these different subsurface scattering maps work together to create the final effect of the skin shader. Okay, so that's going to do it for this entire tutorial. Thanks a lot for tuning in, and we covered a lot of stuff. So from everyone here at i3 Tutorials, I'd like to thank you for your time and for your support. Thanks a lot for watching and choosing us as your training source for Maya training. We're going to be bringing out a lot more Maya training this year, so stay tuned for that. We got a lot of exciting, really neat tutorials and training products coming out, and we're going to be coming out with a lot more free stuff as well on our website that you can check out. So again, from everybody here at i3 Tutorials, thanks a lot for your support. Thanks a lot for watching, and I hope to see you next time.